a exponent x is equal to negative a. You have to solve for x here. There is no way to change negative a to be the same as positive a. Negative a is not equal to positive a. Therefore, here you can't solve that if that is negative. In other words, to solve that exponential equation, you need to have the positive value there. Therefore, a exponent x must be always positive so that you can be able to solve for x there. Again, when you have 2 exponent x is equal to 0. There is no way to change 0 to have the base which is equal to 2 for you to be able to solve for x. Therefore, again, there will be no solution here. There will be no solution. 2 exponent x must be always positive. It mustn't be equal to 0. 2 exponent x must not be equal to 0. So for this to exist, it has to be positive. It has to be greater than 0. Let's say we have 3 exponent x is equal to let's say 27, right. 3x will be equal to, it's 3 exponent 3, the bases are the same, therefore x is equal to 3. And then in a situation like this now, 3 exponent x is equal to 1 over 27. Again here, it's 3 exponent x, we change that, it's 1 over 3 exponent 3. 3 exponent x will be equal to, we take that 3 to be a numerator, we take all these, so it's 1 times that. Once you say 1 times 3, the exponent will change to be negative, which means 3 exponent x will be equal to 3 exponent minus 3. The bases are the same. We can now equate exponents. Right. Now, let's look at this one. We have 6 exponent x is equal to negative 36. We are to solve for x. There is no way to change this to have the same base as that one. But then let's say you are to introduce the log to solve that x. It's log 6 exponent x is equal to log negative 36. It's x log 6 equals log negative 36. And then we divide by log 6 to solve for x. Therefore, x will be equal to log negative 36 over log 6. So, using a calculator to solve that log, there will be no solution, simply because this is negative. In other words, there is no log for a negative number. There is no log for a negative number. There is no log for a negative number. If you have this like that, x, on that case, x must be always positive. Number 2, x must not be equal to 0. Using the calculator to find log 0, it won't exist. But then if you are having log 1, 1 is positive, and again, the base is 10 there. Therefore, log 1, using a calculator to find log 1, you can find a solution here. It will exist if you are to use a log 1 for that. But then, if, for instance, we have 3 exponent x is equal to 1. 3 exponent x is equal to 1. You change that again. 3 exponent x is equal to 3 exponent 0. Therefore, x is equal to 0. Same thing here. Log 1 is equal to 0. Using a calculator. Log 1 is equal to 0. Same as that. When you are to introduce log there, it will be 3 exponent x equals 1 equals, this is equal to 1, and then we are to solve for x. It's log 3 exponent x is equal to log 1. We multiply, it's x log 3 is equal to log 3 exponent 0. We take this and multiply to that. It's x log 3 is equal to 0 times that coefficient, which is 1, it will be 0, and then 0 log 3, it's 0. And then when we divide here by log 3, we want to solve for x, we divide by log 3, we divide by log 3, 0 divided by any number, the answer is 0. The answer is 0. Same as what we have obtained here. When we look here, whatever we get from log will be the same as when you are solving using exponent, which means this is the inverse of that. Right. Now, we have b exponent x. Let us make a b to be 1, for instance. If we have 1 exponent x is equal to 2, we want to solve for x. So 1 is the same as 2 exponent 0. Any number to power 0 is 1. So it's 2 exponent 0 times that exponent, which is x. We want to solve for x here. This is equal to 2. The bases are the same. Remember that 2 is exponent 1 there. The bases are the same. We equate exponents. It's 0 times x is equal to 1. 0 times x is 0. 0 is not equal to 1. We were to solve for x, but now x is no longer existing because our base there is 1. Let's make another example. 1 exponent x is equal to 5. We want to solve again. It's a log 1 exponent x is equal to log 5. It's x log, remember we are multiplying. So it's x log 1 is equal to log 5. Log 1 is 0, right? Let's divide by log 1. We are dividing by log 1. Therefore, x is equal to log 5 over 0. Any number divided by 0, it's undefined. This means that here we've got b, where we are saying this must be always positive. But now there is another thing that we have picked up, that if our base, this is our base, if our base is equal to 1, the whole of this won't exist. So that means here, b, the value of b, which is our base, it can be either b, c, or whatever number, b must not be equal to 1. So now we've got this restriction which says the whole of this exponential equation must be always positive. Again, the base now, as it is, it mustn't be equal to 1 for this to exist. In an exponential equation, whatever base there, it must not be equal to 1 for it to exist. Let's continue. So now we are going to do an exponential function. An exponential function. It's a function, f at x is equal to a exponent x. F at x is equal to a exponent x. Right. For this to always exist, we are saying a exponent x must be always positive. That's the first thing. Secondly, a must not be equal to 1. Again, when we look there, we've got x as an exponent there. We can put any value of x. Any value of x. Let's say our a is 2. A equal to b, for instance. And then we are to solve for b. If x is equal to negative 3, for instance, if x is equal to negative 3, solve for b. If x is equal to negative 3, solve b. Solve for b. Right. Here, where there is x, we are going to put minus 3. So when you look here, this is existing. b is equal to 1 over 8. This is existing. It's either you put a positive value of x or a negative value. b will be always existing. In other words, we are talking about the value of x. Remember that x is, when you talk of the value of x in terms of restriction, it's a domain. Therefore, for the domain here, for the domain, x can be any value. X can be any value. That's a domain of an exponential function. X is an element of real numbers. X can be any value. This will always exist. Right. Now, let's say we have this function. F at x is equal to 2 exponent x. And we are to sketch this function. We are to sketch this function. When we look here, if we can put 0 that side, this won't exist. if we can let y to be 0, this won't exist. In other words, y must not be equal to 0. When we have the x-axis like that, this means that our function, which is y, must not touch the x-axis, this function. Because once you make y to be 0, it won't exist. 2 exponent x is equal to 0. You can't solve this. That's the reason why we are saying this function must not touch the x-axis. So if that's the restriction for us to sketch this graph, which means y is equal to 0 is our range. Because we mustn't touch here. We must not touch here. Y is equal to 0. It's a restriction for us not to touch here. So, for this graph to exist, it has to be above where y is 0. Y is equal to 0. This blocks us along horizontal line, which means this will be our horizontal asymptote. Horizontal asymptote. It's our horizontal asymptote. But then remember, we said in terms of x, there is no value of x that can block us vertically. We can move to any direction. X can be any value, can be 0, can be any value. That's why we are saying for the domain, x is an element of real numbers. But for the range, we can't make y to be 0 because this won't exist. Y is equal to 0 is our horizontal asymptote. Let's sketch this graph. In order to sketch an exponential function, we find the y-intercept and the x-intercept as usual, and then we indicate the asymptote. Our asymptote, obvious, is the x-axis. Therefore, let's find the other points. It's -2, 0, 1. When we are to put a -2 up there, this is the same as 1 over 2 squared, which is 1 over 4. Therefore, we're going to have 1 over 4 there. It's 1 over 4. Putting -1 in the place of x, we are going to get 1 over 2. Putting 0, any number to power 0, it's 1. Put 1, we are going to get 2. Right, let's sketch this graph. Let's sketch the graph. It's 1, 2, 3, 4. We've got -2 is to 1 over 4. 1 over 4 is a quarter. So if x is equal to -2, y is equal to 1 over 4, just below half. That point should be there. If x is equal to -1, y is equal to 1 over 2, that's half. And then if x is 0, y is equal to 1, there it is. If x is equal to 1, y is equal to 2. Right, let's put 2 also here. our table. If x is equal to 2, 2 squared is 4. Therefore, goes there. Remember, our graph must not touch the x-axis because it won't exist. That's the function of f. 2 is to 4, 1 is to 2, here 0 is to 1, negative 2 is to 1 over 4, negative 1 is to 1 over 2. Right. That's how our graph would be looking like. Start from where x is negative up to where x is positive. It starts from where y is a smaller number, which is a quarter, up to where y is 4, which means our graph is increasing because x is increasing, also y is increasing. This is an increasing function. Increasing function. Right, just a same function. Let's change our exponent. Same function, let's change our exponent. Let's say we are having g at x is equal to 2 exponent negative x. This is exponent positive x. And then here we are having exponent negative x. Right, again here, if we can put 0 there, it won't exist, which means our horizontal asymptote y is equal to 0. Our horizontal asymptote. Y is 0. Y is equal to 0. Right. Let's sketch this graph. And then we've got x here, negative 2, negative 1, 0, 1, 2. Putting negative 2 there, we are going to have 2 exponent minus. In the place of x, we put negative 2. So negative times negative, it's positive. This would be 2 exponent 2, which is 4. When we put negative 1 here, negative times negative, it's positive 1. 2 exponent 1 is 2. Let's put 0 now in the place of x. If x is equal to 0, negative times 0 is 0. Any number exponent 0 is 1. And then put 1 in the place of x. So now we are going to have 2 exponent minus 1. 2 exponent minus 1 is the same as 1 over 2. Again, when we are to put 2, negative times 2, it's negative 2. 2 exponent negative 2, it's 1 over 4. Let's sketch the graph. Let us sketch the graph. It's 1, 2, 3, 4. If our x is negative 2, y is equal to 4. X is negative 2, y is 4. There's our point. X is negative 1, y is 2. That's our point. X is 0. When do we let x to be 0 for the y-intercept? Which means our y-intercept is there. X is 1, y is half. So half is somewhere there. X is 2, y is 1 over 4. And then it mustn't touch the x-axis. It must not touch the x-axis. Right. Let's join our points. It approaches the x-axis, but it mustn't touch the x-axis. This is the function of g. Negative 2 is to 4. Negative 1 is to 2. Our y-intercept 0 is to 1. 1 is to 1 over 2, and so on. Right. That's how our graph will be looking like. X is equal to negative 2. Y is equal to 4. And then x is increasing to negative 1, but y is decreasing to 2. X is increasing to 0, y is decreasing to 1 from 2. X is 1, y is 1 over 2, which means this is a decreasing function. It's a decreasing function. So if that coefficient is positive, our graph is increasing. Whereas if that coefficient is negative, our graph will be decreasing. Right, let's look at this one now. We are saying if the exponent is negative, that will be a decreasing function. But that's not always the case. Let's look at this. H at x is equal to 1 over 2. Exponent x. The exponent is positive. Our exponent is positive. Right. Let's sketch this graph. Right, it's our y. We are to substitute in the place of x. We have 1 over 2. 1 over 2 is the same as 2 exponent negative 1 times. In the place of x, we put negative 2. Negative times negative is positive, which means this is 2 exponent 2, which is 4. This is 2 exponent 2, which gives us 4. We are going to have 4. Again, when you are to put negative 1, you're going to get 2. When you are to put 0, we are going to get 1. Put 1 in the place of that, it will be 1 over 2. It's 1 over 2. When we are to put positive 2 here, this will be that, which means our answer is 1 over 4. That's 1 over 4. Let's sketch the graph. But without even sketching the graph, we've got same values here. This table is the same exact as the other table, which means our function is decreasing. But look, our exponent is positive. What is it that makes this function to decrease? is the base. So if the base in this case, let's say we have y is equal to a exponent x. A exponent x. In this case, if a is greater than 1, let's say it like that. If a, the base, is greater than 1, when you say greater than 1, that means it can be either 3 over 2 or any value that is greater than 1. It can be either 2 or 3, but greater than 1. The function will be increasing. Whereas if A, remember this is our A, the base. If A is less than 1, if A is less than 1, any fraction less than 1, 4 over 5, 6 over 7, 1 over 3, 2 over 3, all these values are less than 1. That would mean the function will be decreasing. The function will be decreasing. The function will be decreasing. Right, why we are still there? We are saying if A is greater than 1, but A is greater than 1, but also the exponent must be greater than 0. A is greater than 1, also the exponent is positive. Here, exponent